Okay, so this last topic is called the chain rule. It's actually yet another differentiation technique to give you more flexibility and be more effective. And if you guys could put your phones away, please, thanks. So that you can actually do derivatives in a more efficient manner. Just gives you more flexibility. And it's a rule that definitely plays a big role in everything you do afterwards. I wish I could still teach you guys, keep teaching you guys calculus, but time's almost up, right? So but we dy over dx, that's a derivative. If you have y equals x cubed, we know how to find that derivative. We know it's 3x squared, right? So that's pretty easy, right? This right here, y prime is 3x squared. We know this. So the chain rule kind of follows the same thing, but you apply the chain rule for things that are composite functions. Like, for example, x to the fifth then raised to the third, sine x raised to the third, or x to the fifth plus 2 raised to the third. It doesn't have to be raised to the third, it can be raised to any other power. But if I were to work this out, I mean, I know what happens, right? I know that's y equals x to the 15th power. And if I do the power rule, I get this, right? Like we know this, that's 15x4. But what you could do is you could also do something like this here. Move the 3 to the front, drop the exponent by 1, but then we run into a problem. So that's 14. My apologies, not 4. My apologies. It's 15x to the 14th power. But if you try doing it, the power rule with this, right? Like if x to the fifth raised to the third, move the 3 to the front and drop that by 1, you get 3x to the fifth squared, or 3x to the 10th power. Is that true? Is that truly the derivative x to the fifth raised to the third? That was supposed to be this, right? So that's not true. So you have to be careful here, because some people might think, oh yeah, let's move the 3 to the front, drop the exponent by 1. So what is dy over dx? It's going to be this. So great, we just expanded it and then took a derivative afterwards. But you don't have that luxury. Please, too, especially for sine x raised to the third power. And this right here also, like you have to FOIL this 3 times, right? X to the plus 2, x to the plus 6, x to the plus 2. You do it, but it's not fun, right? So again, this is not true. If you have x to the fifth plus 2 raised to the third power, yes, you move the 3 to the front, drop the exponent by 1, but it's not going to be the whole story. Because we even solved with x to the fifth raised to the third power, it's supposed to be 15x to the 14th, not 3x to the 10th. So what we're going to do, I'm going to take kind of a painstaking way to do it, and then I'm going to show you the chain rule afterwards. And chain rule will save you a lot of time. So the painstaking way is to actually FOIL the sucker, right? So if you FOIL it, remember, if you raise them to the third power, you get this. So I have x to the fifth plus 2 cubed. It's going to be x to the 15th plus 3x to the 10th times 2 plus 3x to the 5th times 4 plus 8. And then if I take the derivative, if I do y prime, because that's what y equals right now, that's 15x14 plus 60x9 plus 60x4, and that's it, right? Yeah, because remember, that's 12 x to the 5th. That's 6x to the 10. And so, yeah, that's what happens. I mean, it wasn't so bad, I guess, to FOIL it. But there's something else we could do called chain rule. I'm actually going to show you the chain rule right now and then explain it down below. Here's how it works. If you want to take the derivative of all this junk here, right? You still do the power rule like you usually would. But then you have to multiply by the derivative of the inside. If you do that, you get this. So a little accent mark means derivative. I'll go and expand this while I'm at it. What's derivative of x to the 5th plus 2? 5x. Yeah, 5x to the 4. And if you were to distribute, what do you get? You will get 15x 14. Oh, look at that. 3 times 4 times 5, 60x to the 9. Oh, 3 times 4 times 5, 60x4. You get the same exact thing. Now, personally, I don't care if you expand it. I'm cool if you just leave it in factor form like this. I'm totally comfortable. Like, sorry, the second line. I'm totally fine with that. But yeah, I don't care if you expand it. Leafy doesn't care either. They just, want you just to do the correctly. But If you were to expand it and do the power rule for each term, of course you get this. This multiple choice question is presented this way, then I guess you would have to expand, which kind of sucks, but this is called the chain rule. So what you do is take 3 on the outside. So 3 is on the outside, and we 3 to the front, that by 1, keep it inside intact, and then multiply by 3 on the inside. That's the chain rule. Do you have a question?
For the final answer, do you want to sort of boil out?
I don't care. I don't care. Yeah. Yeah, I don't care. I know I did. So this is called the chain. It looks a little confusing at first. So what they do is they write y as a function of u, and u as a function of g of x. So it's a composite function. So basically it's f of g of x. That's what you're looking at, f of g of x. And if you take the derivative, it looks like this. F prime g of x. That's really what's happening. That's truly the chain rule. You have a composite function, g of x inside f of x. You take rid of f, the outside function, keep g of x intact, multiply rid of the inside. They do these using whatever. That works. Want to do it that way. I don't really teach that way. I just say, hey, just take rid of the outside, multiply rid of the inside. That's how I go about it. So, and we already worked this one out. We already know what happened here, so we don't have to work it out again. Questions before I move on to page 2. Now, this one thing, actually, I'm going to print this right now because I realize I haven't done this for you guys, but I think now is a good time to do it. And actually, I've had other AP Calculus teachers, not to brag or boost my ego, but I've had other AP teachers tell me they're really impressed with this. So this is actually a nice little cheat sheet of derivatives that we've done so far. The limit definition of the derivative right there, both alternative and regular. Derivative constant, give you an example. Derivative constant multiple, give you an example. Some difference rules, explain. Power rule, I explain. Product rule, quotient rule, chain rule. We're not going to do this. I'm really sad we're not going to do this because I really like this technique. Implicit differentiation. You'll do that. That's the first thing you do when you come back in August. Day 1, you'll do that in AP Calculus BC. So I pass out the baton. Ms. York most likely will be teaching the class. Pass the baton to her. She'll teach you that day 1. We're not going to do inverse functions. But trig, we did trig. We haven't done inverse trig, so that's not going to apply. We haven't done that stuff. If we finish chapter 4, you would see all this stuff. But this is a nice little cheat sheet. So I'll print this for you guys. This will help you guys study for the test. So actually, let me do it right now. Yeah. So this prints. Okay, cool. Anyway, let's keep moving with the notes, guys. Here we go. All right, so let's do the chain rule. Here we go. So for this one, you could expand it, but I'll just do this. Y prime equals 5. Because to FOIL that 5 times is crazy insane. Please don't do that. But what's the new exponent after I drop it by 1? 4 times the derivative of the inside. What's my inside? What's the derivative of my inside, guys? Yeah, and leave it like that. I do not want you going any further. Just stop. Do not go any further because you're going to drive yourself nuts if you do. It's not necessary. Completely unnecessary. In fact, actually, if you're like being asked, like, find me the equation of a tangent line, you got to find the slope. You got enough anyway. Like if I said, find the equation of a tangent line, x equals 1. So this will get you the slope, right? Because we're going to get you the slope of the tangent line. Great. Let's see. Plug in 1, you're good. Work it out, and you get the slope of the tangent line anyway. So you don't need to expand it. It's not necessary. Now, why do we have chain rule? Because how are you going to do something like number 2, right? I mean, cosine 5x is not, yes, I know the derivative of cosine is negative sine, but it's not enough to say that. You must also do times 5. You must also do that, right? And here's the deal. And also, can you put connections away, please? So I can see it right in front of me. So you're not hiding anything. All right. Is it hard or how's connections today? I now do it late at night. I used to do it in the morning. I now just do it before I go to bed.
Not for connections.
Not for connections. Yeah. So anyway, but how can you check your work? Just so you know, we've talked about this already. If you go to hold on. The graphing calculator, math departments, Wabbit, EMU.
Why does that little problematic?
I don't know. No idea. Kind of funny. But if I go to y equals cosine 5x, and if I do alpha window option 3, then alpha trace y1, or you type in cosine 5x again if you want, x equals x, and then I do negative 5 sine 5x, turn it off, make sure you're in radian mode. I'll graph in the z trig window. So there's the first graph, right? And it takes a while because it's, you know, doing a derivative of cosine, right? So it's taking a sweet little time. Okay. Kind of just wait it out. And it's doing the next one. And how come I don't see another graph? It's tracing over it, right? And you can see in the far right corner, once it stops thinking, I've hit trace. Right now, so look at the top left corner, it's y2. If I trace, like it's giving me all these, you know, points on that curve. If I hit the down key, I'm on the same curve still. Nothing changed. That's not how I know I've done it right. Or you could even do this. Put alpha trace and just plug in a value, like say, I don't know, 1. Nope, sorry. Alpha trace y2. Plug 1 in, see what the output is. Awesome. Do it again, but do it for y3. Plug in 1. Great, you get the same thing. I mean, yes, it's off a little bit, as it should be, because remember the derivatives an approximation, right? It's off a little bit, not a big deal. But yeah, it works. So we're okay. Not a problem. So that's how you can check your work. So our next test will also be calculator allowed as well. So let's do this again. Y prime is 3. It is. I mean, so the first 30 questions are non-calculable choice. And then there's a calculator portion that's 15 questions that comes after multiple choice. And half those questions actually do need a calculator. You'd be totally hosed if you don't have one. And there's actually a special way, like what I'm showing you right now, all those special tricks and whatnot, that's part of it. You have to do that. But once you learn about antiderivatives or integral calculus, there's even another skill set associated with that. So you have to, you got to be very proficient with the calculator. Then you take a break, and then you do the free response. 6 free response questions. 2 of them are calc, and then 4 of them are non-calc.
How long is this even?
See, it's an hour and 45 for the multiple choice, an hour and a half for the second. So it's 195 minutes total, with a 50-minute break in the middle, so 3.5 hours with standard time. So double time, you're taking about 7 hours.
That's insane.
7 hours for a double time, yeah. I know it's totally crappy. Yeah.
So there's 51 questions.
It's a 45 multiple choice and 6 free response, right? And they're weighted equally as well. They give you more time for the multiple choice calculator because it takes time to kind of punch stuff into the calculator. So they give you 45 minutes for that, so 3 minutes per question. But for multiple choice non-calc, they give you 60 minutes for those 30 questions, so 2 minutes per question.
2 minutes per question for 30 questions.
Yeah, you got to use good test taking strategy for sure. So you don't burn yourself on time. Okay, guys, let's finish this off. So this should be this 1/2 root x minus 1/x squared. I hope you guys remember the derivatives of 1/x. That's x to -1. So if you do derivative of x negative using the power rule, it's -1 x to -2. Hope that makes sense. It's x to -1. So move that 1 to the front, drop it by 1, get that. Move that to x to the half, move the 1/2 to the front, drop the x by 1. So it's 1/2 times x to the -half, or 1/2 root x. So that's what happens. And this is the rule I really like. I mean, sorry, this is the explanation I like. Derivative of the outside, keep the inside intact, times derivative of the inside function. That's chain rule. Yeah, Ryan, go ahead.
What was the second?
Sorry, -5 sine x. Sorry, -5 sine 5x. Okay, so that gets us done. Oh, we still got this problem here. Yeah, just do the same thing. Y prime equals cosine. I'll put a 7 on the outside because I know that's going to be outside when I do the derivative of 7x minus 1. Tangent of secant squared. So plus 9x
Maybe
times-
it's not on the test, but,
100%. That's why I printed the cheat sheet for you guys.
like, yeah, on the test, we have,
What was that?
we don't have like training.
Do nothing. So they could do nothing. I'll do nothing. Sorry. You're right. Even those with the format sheet accommodation, I don't give it to you. Because you gotta know it.
That's, well, that's usually the combination.
For those some people might have it. Yeah. Yeah. So but
There's no.
but yeah, you have to you gotta know it. So okay. Let's keep moving. Okay. So sometimes you have something called double chain rule. That'll be an example. Well, actually, I don't know if we yes, Stuart. No, we're not doing it quite yet. We're gonna do a double chain just a little bit. That's example 8. So just more of the same stuff. Just know your, like if I look at the cheat sheet, cosecant is negative cosine cotan. So you just go through the motions. That's all. Like y prime is negative cosecant of cotan x times cotan of cotan x times negative cosine squared x. And next, let me change the color of these as well. So that's your inside. Keep the inside intact, and that's your outside. Exactly. I know it's kind of funky.
Wait, can you spend that 5 dollars?
I'll slow it down. I know it's a little funky. So the outside function is cosecant. The derivative cosecant is cosecant, sorry, negative cosecant cotan, right? So I took the derivative cosecant, which is negative cosecant cotan, and I put these little blanks here. And what I put inside the blanks, the inside function, which is cotangent. And then I take the derivative cotangent, that's my inside, and that's going to be negative cosecant squared x.
Okay, yeah, but when did?
Because we're cotangent cosecant squared x, we're cosecant negative cosecant cotan.
Oh, okay.
So what I've done is that the outsides are in red and the inside is green. And of course, I just did that because I thought it was good.
Yeah, that makes sense.
So seriously, there's no work to show. You just have to know the answer. That's really what it comes down to.
You respond to that.
No, this is never asked as a free response. Never. It's a free, this is a multiple choice question.
Three responses.
Like, through, like continuity or like.
Sure.
Does that mean the test is gonna be like a lot of more places? So.
45.
45 multiple choice to 6 free response. And it's weighted equally. Good question. No, I'll just have it kind of like, here's the derivative, just find it. You know, I mean,
What about AP Calc? That does multiple choice.
not really. No, I mean, sometimes we throw a couple multiple choice, but the final exam is though. The final exam is designed like an AP. Because-
I remember like. we took the-
But you guys are, since you guys are asking,
Yeah. I saw.
I heard about this.
She was Joe.
so the free response again, it's not gonna make too much sense because you guys haven't done second semester calculus. It's like I hardly ever do AP style questions in the first semester because you just can't. It's too hard. But like there's something like this you might be able to handle. Like for example, we've done velocity and acceleration, right? You should be able to do that, and that's a quotient rule. You should be able to handle that question. I think that's fair. Speed, we talk about the absolute value of velocity, right? Should be able to do that. That's not hard. But position, that requires an antiderivative because now you're going from velocity to position. You have not learned that yet. You will learn that this fall. Yeah, that's another one that you'll have to do in the fall. This one you can't do because you haven't learned about how to deal with rates and how to integrate it. That's integral calculus. But see how like they have some piece of information and they have like 3 or 4 parts that pertain to that piece of the information. Yeah, a lot of these things you're not gonna be able to do. These won't make any sense to you right now. So yeah, anyway, that's how it looks. This one, could you do? No. So all right. Okay, let's keep moving, guys. All right. Now, who cares if you're using like R and theta or X or Y? It's all the same thing, right? So that's easy. And by the way, if you see something like this here, you guys should know that means sine x raised to the second power. So actually, let's prime it first and write it like this. Let's do that, and then do r prime. That's raised to the 1 power times root of sine, which is cosine theta. So altogether, dr over d theta equals 2 sine theta cos theta. Okay. So just make sure you're comfortable with that notation. Also be very mindful. Like if it seems something like this here, you know, sine x raised to negative power. But see that's inverse sine, it's not this. So be mindful about that. And we won't cover inverse trig functions in this class, unfortunately. You'll do that usually day 3 to day 4 in the fall. So oh yeah, no, Ms. York, she's gonna oh yeah. Good. Yeah. Okay. I did tell you that collectively you guys are one of the best groups I've ever worked with. So she's expecting great things out of you guys. I know you guys will do it. So all right. Okay, here you're gonna do a product rule with a chain rule. So here's what I'm gonna do. I'm gonna color code things to make things a little easier for us.
Oh, do you have like a cheat sheet for the presentation?
I don't, but it's in the notes. Yeah, it's on the 3.3 notes, I think, or 3.2 notes. I think it's the bottom of the first page. Okay. So what I'm gonna do is this x to the 5th derivative plus okay. So what I'm doing is I'm kind of just showing you the process. I don't want to just go straight to it. Just make sure you guys understand what's happening. I think it's just 2 functions, right? X to the 5th is 1 function. So like x is 6 it's like f and g, but you're like that's right. F prime g plus f g prime. F prime g plus f g prime. So the first part's pretty easy. That's just 5x4, right? 5x4 times 7 minus 2x raised to the 6th power plus x 5th. Now careful here. Very careful here. That's going to be 6, 7 minus 2x raised to the 5th power times what's the root of the inside? Boom. Got it. Let's clean up just a little bit. Well, hold on. Trying to think how to clean it up. X4. Yeah, I think that makes sense, right? Because that's negative 12x. You took out x4 and all this right here. Here you took out x4, but kept 7 minus 2x. You took out 7 minus 2x to the 5th power. Cool. If you want to clean up the inside, go ahead. I don't care. Actually, I think I might make this multiple choice question and kind of force you guys to clean up just to make my life easier for grading it. I don't know. I haven't thought that far ahead. So okay, let's keep moving. Okay, this is a double chain rule. You'll see why it's called double chain just a sec. So you basically have a function within a function within a function. So it's like saying f of g of h of x. So we take the derivative of all that. When we take the derivative of all that, it's going to be this. F prime Does that make sense what I'm doing? It's kind of like, oh, perfect. Totally unintentional. You guys know what these are, right? Yeah, these little Russian dolls, yeah, it's very bonds, it's all weighted up. Yeah, this is what when he was with Pirates in 1990 and 92. This is or sorry, 85 to 92, 89 times to 93. When he was standing, he's only actually still 50 bases. I think 30 numbers. This one he was sitting like 7 numbers. And then there's going to take care of those things. So I think it's another one. No. But like think of this as like h of x, right? You like h of x? This is g of x with the Pirates. And then he came to the Giants and wrote it up, still wanted some well actually no wants the title. He never you guys are too young to know this, but 2002 when we were in the World Series, he refused to slide to catch a ball. I was so pissed. But we also our manager overmanaged the game, but we won 3 titles, so it's okay. Yeah, so it was game 6 of the World Series against the Angels. And Giants had never won a World Series in San Francisco up to that point. And I remember I was actually Yerba Buena Gardens, like the whole series ready to erupt. We're up 5-0 in the 7th inning. And our manager, Dusty Baker, finally won a chance for the Houston Astros, but was notorious for choking. Decided to take the pitcher out because he was got in a little trouble. And of course, the relief pitcher serves up a 3-run homer. So we're up 5-3. Then there was some ball that was hit towards Barry Bonds. He could have slid to catch it to end the inning. He didn't. And they get another homer, and they're up 6-5. So, yeah. The Bonds never won a championship as a result. So, anyway. But then we won 3 more, so it's all's forgiven. So you just move on. Anyway, let's see this problem. I digress with the sports. What's the outside function? What's the outside function, guys? What's your F? And what's your G? And that's your H, right? So what's the derivative sign? Cosine, right? So be cosine of and keep the rest intact. So I'll change colors for a bit of contrast. Totally unintentional, black and orange for the Giants. So here we go. Cosine of x squared minus pi times, now let's do the G part. That's what's the derivative of cosine? Negative sign, keep the rest intact. And then the H part, what's that going to be? Just 2x. There you go. It's not that hard once you get the hang of it. That's your double chain.
You could do like however big chain you do F prime of the whole thing, then G prime, the middle thing.
Yeah.
Down to
Until you whittle your way down to the last one. Exactly. Right.
Wouldn't you have to do another chain to like separate the sign and square and like
Well, sorry, say again.
times the sign?
Yeah, what about that? No, because now you're doing a second derivative. If you do that.
Oh.
Yeah, because now you're doing the derivative of derivative. No, you're just one derivative. Just follow. It's a chain reaction in a way, right? That's what they call a chain rule because it's like these links to the chain. So what you're trying to do is you're applying this principle to this long chain, right? But then what you're doing is that then you're applying the principle again to the particular link. This is the link of the chain. You only want to do this once. But what's happening is that if you decide to do this again, now you're doing a second derivative. And that's messing it up. You don't want to do that. Actually, it's not truly a second derivative. I'm just doing something crazy.
It's like part of this second.
Yeah, exactly. Now, this is a problem I love a lot. I love this problem because this is actually how it's done on the AP. And it's also forcing you to use these processes. It's forcing you to do product rule, chain rule. Also, some of the stuff's superfluous. You don't need all this information. You have to be able to filter out, like, you're not going to use all this information here. Maybe just use only 2 or 3 pieces. So it's kind of like a puzzle. I really love this problem a lot. This is definitely a test problem. And maybe even a final exam problem too. Okay, so this is product rule. And you can't really, a calculator can't really help you because I didn't give you the equations, right? I mean, yes, you can use a calculator for a computation, for arithmetic, but you can't plug in the derivative thing because you don't know what the equation is. So let's do it. 1/2. I'll put a bracket. F prime G plus FG prime. And here, that's going to be F prime G times G prime. Okay, remember, we're plugging 5 in. What's F prime 5, guys? What's G5? What's F5? And what's G prime 5? G prime 5? 10. You get negative 13. Yeah.
There's 3 functions multiplied by.
Ooh, good question.
You have like 2 steps of product rule.
Yeah. Yeah. You would. Yeah. I'm gonna put that on your test. I like that. Yeah. Okay. Now I can show you really quick when I finish just how that will look. It's kind of a funky question. That's a good question. Okay. Next up, this one here. So doing F prime of G of 5 times G prime of 5. Now what's G of 5, guys? 7. What's G prime 5? That's 10. What's F prime 7? So you get negative 10. Is that okay? So again, you had to evaluate G of 5 because you had to keep it inside intact, which is 7. Notice we never even use this piece of information. We never even had to use that piece. I did use this one. I did use each of these, but I never used that one. That was there 3 off. So. Okay, let's take a look here. Think of it like this. G of x raised to the 3rd power. So if I take the derivative of that, does that make sense what I just did so far? And I'm putting 5 in, right? What's G of 5? 7, okay. And G prime 5, 10. So 7, 10. What's that going to be? 1470? Okay. And remember, you could write it like this for part D, but it's not an inverse function, right? So let me sneak this one in here. Does that make sense what I'm doing so far? And then times what? It's a chain rule, guys. Times.
When you have f of x, you have to assume it's another function.
100% correct. Yep, it's composite, 100%. That's the mindset you have to have. So y prime is going to equal -1 over f of 5 squared. Well, what's f prime 5? 2 and -4. Okay, so we have -2 up top. and 16 sorry, what was that 5 again? My short-term memory stinks these days. Wait, hold on. -4. Sorry, guys. But no, I'm right. Am I right? F of 5 is -4, squared is 16. Yeah, I'm right. F prime 5 is 2. Okay, so you get -1/8. And just for my own sanity, I'm just gonna pull up the filled out notes. Just make sure I got this. Yep, -1/8, 1470, -10, whatever. So cool. Okay. -1/8. Okay, the last bit. So we said that the derivation of the derivative of sine and cosine, we had assumed radians. Why do we assume radians? If you try switching to degrees, you'll get a much different response. What time is it, by the way? It's 1:17. We got what time?
30.
Like we got some time that I can finish this up. Okay. So here's the deal. If you plug this in a graphing calculator, right? Let's go back over here. And let's say I do sine x. Let me clear this one. Turn it off. Mode. Z-trig. So what is it graphing? It's graphing cosine x, right? Because it's graphing derivative sine for me. Now, if I switch my mode to degrees, what do you think is happening here? What's the conversion between degrees and radians, guys? Yeah, exactly. So let's think about it.
X to the 0 or X like that?
X degrees, sorry, X degrees. My bad. That converts to radians. So if I were to incorporate that, you guys don't have to really write anything down for this. I used to not cover this with my AP students, but I just feel like doing this to you guys. But if I do this, oh, that's weird. It should be. Oh, I got to switch back to radians. Wait. Wait, why is it not doing it? Should be doing it. That's weird. Or maybe I have to reverse it. Hold on a sec. There we go. Yeah. Okay, so I guess I should have done it the other way around. I don't know why. Yeah, so I'm in degree mode. So you can see that you have to change it up. So yeah, I don't know why did I'm a little confused actually. But anyway, what's supposed to happen is this. That's gonna be, yeah. No. Yeah, I don't know why. Oh, you know what? I know why, because you're going from radians to degrees. I got it. Okay, that's where I messed up, guys. My apologies. X degrees equals this. I totally got this backwards. X degrees equals X radians times 1/8 pi. My bad. So that's what I do here. I had to do that. If you do the derivative, what's going to happen is you do a chain rule, right? It's 1/8 times cosine of all that kept intact. So that's why we assume radians. So because it's otherwise you'd have to do that. So we don't deal with degrees because it's such a pain. I'm not gonna do the second derivative. That's just I don't want to do that. This is too much. So let's not even worry about that. But you guys get the idea. You do the chain rule again. So anyway, that's what's happening there. It's not in the test. Don't worry about it. Just something to talk about. All right, we're all done. That's it. No more new material. You're done with new material for about 3.5 months.